Okay, so the next kind of factoring we're going to do is the difference of squares. I'm not really good at spelling with this thing. It doesn't like that sometimes. Difference of squares. Okay, and that type of factoring, you're going to look and see difference again. Remember is subtraction, just to see if this is a perfect square and this is a perfect square. And you want to do that because the only way that this thing can be factored other than GCF is again a foil looking problem, and you just take the square root of each one of these things. So, or you think about what times itself will give you 4x squared. So this will be a 2x, this will be a 2x, and then this is going to be a plus 3 and a minus 3. Because again, remember, you got to get a negative 9, and the only way to do that is if one's positive, one's negative. And if you notice, if you do your inners and outers, this gives you negative 6x, and this gives you positive 6x. So this comes out to be 0. That's why there's not 3 terms. So technically, this is what you should. This is really a trinomial in disguise. It just happens to be that the middle term is 0. So that's why you're still factoring it to make it look like a FOIL problem. All right. So let's say you had. Let's do a different one so you can kind of play around with that a little bit. All right. So let's say I had 16x squared minus 49y squared. Let's say it's something like that. First of all, I think about GCF, and again, there's no GCF, so you would think about what squared got you those things. So 4x times 4x is 16x, and 49, you just have to, again, you have one of each sign. This would be 7. Now, in order to get y, I'd have to have a y here. So that's what it would look like. Okay? All right, so that's how you pretty much do that. Now let's do one. If I throw one, and let's see if we can make one so it looks like it's um, not really a. Let's see. We'll do 3. Let's do this one. All right. Now, even though that doesn't look like a perfect square, it's because you haven't taken out the GCF yet. So if you take out the GCF between 72 and 50, you get to take out a 2. And if you notice, once I take out a 2, miracle of all miracles, here I end up with, whoops, I end up with 2 perfect squares. So I would then do this thing again. This would come out to be 6x and 6x, plus and a minus, and the square of 5 times 5 will give us 25. And again, remember you took out a 2, so a 2 is along for the answer. And there you go. And that's how that works. So there's not too much to it. Another thing you need to know are things called perfect square trinomials. Perfect square trinomials. And again, these will be 3 terms. Okay. So you're going to see things like 25x squared plus 40x, let's see, plus 16. All right. Do these have anything, any GCF? 25, 40, and 16? Nope. All right. So again, what you're going to do is something like this. Now, if you notice, the signs are positive and positive. So again, we have 2 pluses here. But now, is this a perfect square? Yep. So I'm going to put a 5x and a 5x here. Is this a perfect square? It is. Now remember, you're not looking for this to be a perfect square because remember our inners and outers add up to be 40. So this would be 4 and 4. And if you notice, if I multiply this, I get 20x. And if I multiply this, I get 20x, which is exactly what 40x is equal to. So you don't have to worry about the middle terms being a perfect square because it just works out. Now remember that even though your answer you have is this, there is another way to write it. The SOLs are famous for writing it in a different way. It would look like this, with a little 2, meaning there's 2 of these. So probably the SOL selection will be like that. And I think I only need to do one of those because it's pretty self-explanatory because everything else is pretty much the same. So So basically, if I were doing this every time, I was doing a trinomial. First thing I'd do is GCF. Second thing I'd ask myself is if these are perfect squares, the first term and the last term. If they are, then I would try to factor it this way. And if that's not true, then I'll start just breaking things up like I did in the other videos. All right, so that's it for this, and happy factoring.